Welcome back to our project of making sequence alignment. So in this video, we want to actually program it and implement it in Python. So we have, we have one function, define alignment, which takes as input x and an input y. It wants to transform x into y. By the way, if this is the first video you watch, I highly recommend that you watch my last video, which is a detailed and thorough, explanation of how this algorithm works. Because I will just show how to implement it here, not really explain too much of why. So let's say that we have the same example as in the last video. To DNA, DNA sequences. And we want to send this to alignment, and we want to get returned, at first, we want to get returned just the optimal number of, the minimum number of edit steps to transform x into y. But also in the end, we would like to know exactly which edits to do. So we'll define another function, define solution, that takes as input opt, and m and n. So if you remember from last video, m is the length of x and y, n is the length of y. But let's start with define alignment. So here we first define that n is the length of y, m is the length of x. And then remember that we need to define the opt matrix. And let's just define each element to be 0 to start with. And remember that we want to have, we want to have n plus 1 columns, because we want to have one for the initialization of opt00. And then we want to do this for j in range of n plus 1. So actually for line in opt, print line, see how that looks like. Right, alignment y should look like this, where we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think that's correct. Length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and it should be one more, so that makes sense. Similarly for the column, I guess we would have just one more from this, yeah, and that makes sense. So it seems that we initialized opt correctly here. Then what we want to do is we want to do the initialization still. So that is, we want to do that opt I, 0 is I, opt 0, j is j. And we skip 0, 0 here because it's already 0 from this one. So for each of the first, this is the first column, and then we do the first row. Right, so this is the initialization part. Let's just check if it's correct. Yeah, so 0 here, and then just increment by 1 each step. Same for the first column. All right, so now we want to go through each part, right? We want to start here, and we just want to go and find the answer to each of these, and then next row find a solution to each of these, and similarly. So we go first, we iterate by row, and then for each row we solve for all of the columns. and we start at 1. So I is the row, j is the column. And now we want to do the apply the recursive formula. And just use that opt ij is the minimum. And this is exactly like we saw in the last video. I minus 1, j minus 1. Then remember, we need to have some delta, which checks if xi equals yj. So let's define a delta at the top. So delta, and we can use a lambda for anonymous function here. If they are not equal, then it's 1, else 0. Just one thing here is that remember that Python is 0 indexed. So we need to remember to subtract 1 here from this index to actually get the ith one and the jth one. When we use delta here, delta, and we input xy, let's input I minus 1 and j minus 1. That's for the alignment, right? This is align. Now for the, I guess, delete, we use opt I minus 1 comma j plus 1, and then for the insertion, opt I j minus 1 plus 1. Align, delete, insert. Right. And then in the end, we want to return opt, I guess, m and n. So let's see. Let's just say opt edit steps, and then let's print it. It should be, if I remember, 3 in this case. So we get 3. All right. So this part is correct. Right. This is the initialization part. This is just applying the recursive formula that we saw. So now that we've found the optimal number of edit steps, we actually want to find the steps on how to generate the optimal solution. So then we go to find solution, and we use something called backtracking, which is that we will essentially look at all of the 3 choices that we have, either inserting, align, or delete, and look whichever was the smallest, then that was the item that was added. So we're going to call this recursively. We have the base case: if m is equal to 0 or n is equal to 0, we just return. Otherwise, we can check the cost for each insert or align or delete. So this was the inserting, or the last one, right? This is this one. And then align. Right, pretty much the same as we had down here. And then we also had delete. And then what we can do is we can check which was the best choice. Well, it's the minimum of those, right? And then if there's a tie, we can say that we insert if there's a tie, for example. So if best choice was insert, right? Either, let's say that in the minimum of insert and align are the same, then let's just say that we take insert. Then solution.append, and we just like write insert just to know what we did, plus string of y and minus 1. Right? Remember that this is just 1 index left because Python is 0 indexed. Let's see. We need to define solution here. And if this was the best choice, then we need to also return find solution of that subproblem. So in this case, the x is not changed, right? We inserted, so we just take all up to all of the let's see, the rows, but we go just to the nth column. So remember, Python does not include n in this case, so we just skip the last one because we inserted, and then just send the indices m and n minus 1. Or if the best choice was to align, well, then we just need to append that to align, and we aligned with the last one. I guess else, or else if best choice was delete. Just to make, I guess, the code a little bit clearer, but you can also write else here, I guess. Solution dot append, and then remove, and we remove the x, and we remove the last x. Remember, the minus ones are just here because Python is 0 indexed. All right, we need to also return find solution of, in this case, when we align, we need to go and remove one row and remove one column and subtract the indices by 1. In this case, we need to return find solution of deleting, so we go just to m and we delete one row, but we keep all of the columns. And I think that's it here. What we do now is that we run find solution here, and then we want to return solution, but remember that this entire thing is going to start backwards. We actually want to start from the beginning, so we can just reverse reverse the list, and then we will also get back the solution. What we can do then is print we want to transform plus y, so we want to transform x to y. Let's see, I guess this makes sense to print the beginning. So we want to transform x to y. Minimum edit steps is the opt edit steps. And the way to do it is string of steps. So moment of truth, let's see if the code, no.
Approximately 10 hours later.
So I think I found the solution. The problem is here. We want to, similarly, we want to include all up to including the nth one. So let's rerun it. And we still get an error. So string of steps. All right. String steps. I don't know why I wrote steps. Solution. Right. Now this makes sense. Let's just clean it up a little bit to like this. We want to transform this into this, and the minimum amount of edit steps are 3. We do that by aligning T, insert C, align G, align A, align C, align G, align T, remove G, align C, and insert A, which is exactly the same solution that we found in the last video. So thank you so much for watching this video, and I hope to see you in the next one.